Hey engineers, and welcome to 2.1.4, which is entitled Force Vectors. Today we're going to be talking about forces specifically and when you pull at an angle. I'm going to give you a quick preview. I'm going to skip down to the very last slide and just show you. What if you had like a hook and it's being pulled on by two forces? Right? Like how much force is it, and in what direction is that force acting? That's where we're going. So we're going to be pulling at angles today, an upward angle and a downward. So in a way that they're both fighting each other, because one of these is pulling up and the other one's pulling down. But in a way, they're also helping each other because they're both pulling to the right. So how do we handle that? And believe it or not, that's actually what we do. We break this into how much is this pulling up? How much is this pulling down? Who wins? How much is this one pulling to the right? How much is this one pulling to the right? We're going to add those. Who wins? I mean, not wins, but you're just going to add them up. But inside of free body diagrams, we're pushing at angles all the time. Like if we have an inclined plane, here's an angle. I just did a Google image search for free body diagrams. Here's a sled. Maybe you're pulling it at an angle. We're going to get into trusses because trusses have a bunch of different angular pieces. So let's get started. First thing that we need to know is that forces are a vector quantity. And a vector means that it's got both a magnitude and a direction. So how big and in what direction? Vector notation, sometimes you're going to see like vector A, they put like a line with an arrow above it, or vector B, line with one side of an arrow. This is called vector notation. So you can see these arrows a lot of times to represent that it's a vector quantity. Vectors are represented by arrows, so you can see that there's an arrow right here, and we'll call this I don't know if this has a name or something, but magnitude. Magnitude is how big. In this case, this vector is 3. And you can see it's denoted by, like, there are 3 units. Maybe it's 3 pounds. Maybe it's 3 newtons. I don't know. But in this case, this magnitude would be 3. I'm just going to go with pounds. The direction of this angle is right here. It's 30 degree direction. It's hard to define direction without using the word direction. I don't know how to define direction without using direction. In this case, it's 30 degrees above the positive x-axis. It's really important that you include that second part, because if you just said 30 degrees, this is 30 degrees also, like if you had your vector down here, and that's really, really different. One's pulling up, one's pulling down. The sense is a way to describe direction describing the direction in general. And what do I mean by that? So the sense of this vector, and this will make sense in a second. The sense of this vector is up and right. How is it applying the force? It is going up and it's going to the right. So that's the sense of this vector. We're going to be using trigonometry when we're trying to find these angles and these what we're going to call components of the vector. Number one, if you have a right triangle, if it's a right triangle, there's a lot of things you can do. The angles add up to 180. So if this is 60 degrees, this has to be 30 degrees, because 60 plus 30 plus 90 equals 180. So these are what we call complements. It's a compliment to be told that you're skinny. So I always used to get complementary and supplementary screwed up in geometry, but it's a compliment to be told you're skinny. So complementary means 90. So to be 180, that's not complementary. That is supplementary. So a little something for you. The Pythagorean theorem. A squared plus B squared equals C squared. A and B are the legs of the triangle, and C is the hypotenuse. This is, again, all sort of stuff you should have seen maybe in algebra or if you're in geometry. Sine, cosine, and tangent. We're going to use those quite a bit. There's a mnemonic device called SOHCAHTOA, and S stands for sine, C stands for cosine, and T stands for tangent. So SOHCAHTOA. So the O is the opposite over the hypotenuse. Sine is the opposite divided by the hypotenuse. So for instance, here's theta. The opposite is going to be the one all the way across. Opposite. And the hypotenuse is the longest side of the triangle. Cosine is the adjacent over the hypotenuse. Adjacent, it's hard. Which one of these is adjacent and which one of these is hypotenuse? Sometimes you get those screwed up. The hypotenuse is always the longest one, which by kind of process of elimination, the adjacent side is going to be the one right next to that is not the hypotenuse. Tangent is opposite over adjacent. So we're going to be using these, what are called trigonometric functions, trigonometry, sine, cosine, tangent, on your calculator to be finding some of these components. Physics people, you were given a really healthy dose of this last year or this year, and it's nothing different. It's just an extension of, there's no difference between what we did last year and what we're going to be doing this year. So when we start talking about forces, if you have a force pulling at an angle, remember we said before that it was like 3 pounds at an angle of 30 degrees? The hypotenuse is going to be 3 pounds. The hypotenuse is going to be the magnitude of the force F. So this would be equal to 3 pounds. The adjacent side would be the X right here. And the opposite would be the Y component. So the force in the X component, the X direction, so left and right, the force in the up and down component in the Y direction. Let's say, here we go with an example. So they're giving you this vector. It's 75 pounds, and it's pulling at 35 degrees above the x-axis, or they say counterclockwise from the positive x. So the sense is up and to the right. And what we're going to do is we're going to find the components of that vector. So the question is, how much to the right is this thing pulling? How much is this thing pulling up? And that's what we're going to do when we do this problem. We're going to find how much to the right and how much up this thing is pulling. So here's where you're going to use SOHCAHTOA. So number one, we're going to find the opposite. So we're going to say opposite, and we know the hypotenuse. So which one of these functions uses opposite and hypotenuse? Sine does. So we're going to say the sine of 35 degrees is equal to the opposite, which is unknown, the force of A in the y direction, and the hypotenuse, 75. So we're going to multiply 75 over there. And you're going to just use your calculator to do that. So I'm going to pull out my calculator, and I'm going to take 75 times the sine of 35. So bear with me as this thing loads. The first thing that you want to do in your calculator is to make sure that this calculator is in the degree mode. So I'm going to hit the mode key, and just the third one down, it says degrees. So if I arrow down a couple times, you'll see it says degrees there. That is good. So now I'm going to take 75 times the sine, and the sine for my calculator is right there, of 35 degrees. 35. Close my parenthesis, enter, and I get 43. So this, FAY equals 43. So this thing is pulling up. How much is it pulling up? With the force of 43 pounds. That's good to know. We're lifting up at 43 pounds. Now the next thing we want to know is, how much are we pulling to the right? How much are we pulling to the right? Now for this one, we're going to use the adjacent. So which function uses adjacent? A couple of them. Adjacent. I like to use cosine, because this hasn't been rounded. So I'm going to use the cosine because it uses adjacent and hypotenuse. So I'm going to say the cosine of 35 degrees is equal to the adjacent, FAX. So it's the adjacent divided by the hypotenuse, 75. So again, I'm going to multiply that over. So I'm going to take 75 times the cosine of 35. And you get 61.4. I'm just going to go with 61. So, how much is it pulling to the right? It's pulling to the right at 61 pounds. It's also pulling up at 43. It's really important to know when you're doing problems like this, and you saw that where we were going from the first part, we had that hook, and it was pulling at a couple angles. It's pulling to the right at 61, and it's pulling up at 43. Now, this is the same problem, and now we're just doing it's pulling down and to the right. So you're going to get the exact same numbers. We're going to get 61, and you're going to get 43 using sine, cosine, and tangent. And here's where this comes into play and how this works out. So here's a boat, and two people are pulling on it. So you and a friend are pulling on a boat. You are pulling with 75 pounds. At that angle, at 35 degrees above the x-axis. And your friend is pulling this way, also at 75 pounds. Are you, 75 plus 75 is 150. Are you really pulling the boat with a force of 150 pounds? No, you're not, because you are pulling up at 43. I think it was 43. I'll go back and check my numbers. Yeah, 43 and 61. You're pulling up at 43, and your friend is pulling down at 43. So you are actually fighting your friend right now. You're pulling up at 43 pounds. They're pulling down at 43 pounds. That doesn't do anything because you're fighting each other. But you are pulling to the right at 61 pounds, and your friend is also pulling to the right at 61 pounds. So how much force is totally on this boat? 61 plus 61, 122 pounds. This is how much force you are both exerting at that time. Now, if you were smarter, you would both pull straight forward with 75. You'd pull at 75, and your friend would pull straight forward at 75, and then you'd be pulling with 150 pounds, right? So there's a difference. The angle matters. And using sine, cosine, and tangent, you can kind of start to play with that and figure out, okay, if I'm pulling up and you're pulling down, we're fighting each other. So those two forces, if they're the same amount of force, they're fighting each other and they cancel each other out. And we're both pulling at 61. So we end up with 122 pounds. And let's go to our very last question here. which was that hook from the very beginning. You got two forces. Who wins? How much is the total force on this whole thing? So, let's get started. You've got this 300-pound force. So what I'm going to do, we'll call this, see its vector C. We'll call this the force of C in the x direction. And then we've got another one here. C is pulling right and up. So I'm going to make a right arrow, and I'm going to make an up arrow. The force of C in the y direction. And here's vector D. D is pulling right and down. So I need to make a right arrow, and I need to make a down arrow. Here's the force of D in the y direction. Here's the force of D in the x direction. So, to find those things, I'm going to use sine and cosine. The force of C in the y direction, remember that's the opposite, so that's, I'm going to say it's 300 times the sine of 60. The force of C in the x direction is 300 times the cosine of 60. Remember how I was multiplied in my first examples, I took 75 times the sine, and that's exactly what I'm going to do here. I'm just going to skip over writing those fractions, and I'm just going to go right to my calculator, and I'm going to take 300 sine 60. 300 cosine 60. I get 260 and 150. So, this 260 pounds. This one here, the x, 150 pounds. Good to know. So this one, it's pulling to the right at 150 and it's pulling up at 260. Now, let's solve for our other ones. The force of D in the x direction. Well, I'll do it in the y direction first just to kind of keep it in the same order. 300 times the sine of 30 degrees. And then the force of D in the x direction, 300 cosine 30. So I'm going to go to my calculator, type those in, 300 sine 30, 300 cosine 30, so it's 150 pounds and 260 pounds. So the x is 260 and the y is 150. Oh, shoot. I screwed that up. This is 400 pounds. Maybe you saw that sitting there at home or wherever you're at. I screwed this up. This should be 400 times that. So let me go back here. Pull out my calculator. 400 sine 30. 400 cosine 30. 200 and 350. So this, 200. This, 350. So, whoa. So what's happening? Our hook is being pulled to the right at 200. It's also being pulled to the right at 150. Our hook is being pulled down at 350. And our hook is being pulled up at 260. So, our hook here, really what's happening to our hook, it's being pulled to the right at 350. And it's being pulled down at 90 because 350 minus 260 is 90. So my hook here, this is getting crazy. It's being pulled to the right and it's being pulled down. So we can figure out what the resultant force is by using the Pythagorean theorem. So we're going to go a squared plus b squared equals c squared. So we're going to grab my calculator, and I'm going to go 350 squared plus 90 squared, and I'm going to take the square root of that. $361. So what's the magnitude? 361 pounds. What's the sense? The sense is right and down. It's being pulled to the right and it's being pulled down. And then the direction. Oh my gosh, they're just piling this on. To find the direction, it's that angle. And to find that angle, I'll use the sine, or cosine, or tangent. It doesn't matter. The sine is the opposite over the hypotenuse. So I go back to my calculator, and to move the sine to the other side, I use the inverse sine. So I go to my calculator, and I go inverse sine, second function, inverse sine, 90 divided by 361, and 14 degrees. So this direction, 14 degrees below positive x axis. Woo! What a horrible, horrible problem. Way too much. So today, we learned about using sines and cosines. I know this might have been a little bit long, and it's a review for some of you, for sure, if you went through physics. But using the components of vectors, how much is it pulling to the right, how much is it pulling up, adding like terms, subtracting if they're pulling in opposite directions, Pythagorean theorem, sine and cosine. Thanks.